Yesterday we talked about the mean, the median, the mode, the range, the variance, and this is the formula that I would like you to use for the variance and the standard deviation. So we went up to slide 27, example 2. So today we will talk about the empirical rule. The empirical rule says that if the data follow the normal distribution, normal means bell shape, then 68% will be within one standard deviation from the mean. That means x bar plus minus one standard deviation. 95% will be within two standard deviations, and almost all, or 99.7%, will be within three standard deviations. So keep in mind, 68% means x bar plus minus one standard deviation, 95 x bar plus minus two standard deviations, and almost all, or 99.7, means x bar plus minus three standard deviations. Now for this problem we know the sample mean, it is 64, and the standard deviation is 2.71. So because it says 95%, we are looking for x bar plus minus two standard deviations, because 95% is with two standard deviations. So in this case you do 64, the sample mean, plus minus 2 times 2.71. That means 95% of women are between 58.58 and 69.42 inches tall. Now, measures of position, percentiles, quartiles and interquartile range. So, for the percentiles, we have to follow these steps. We have to put the data in ascending order, and then we have to calculate the index. The index will be the percentile over 100 times n. N is how many observations you have. Now, if the index is not an integer, you round up, and the percentile is going to be the value in this position. Let's say, for example, that your index is 4.8. This is a non-integer, so you round up to 5. So the value of the fifth rank observation is going to be the percentile. Now, if the index is an integer, for example 6, you take the average in positions I and I plus 1. That means if the index is 6, you take the average of the 6th and the 7th ranked observation. In this example, we have 70 apartment rents. As you can see, 425 is the lowest, 615 is the highest, and we want to calculate the 90th percentile. Now, the index, as you can see, first of all, P is 90 because of the 90th percentile, and N is 70 because we have 70 observations. So you take the average of the 63rd and the 64th. Why? Because 63 is an integer. So you take the average of I and I plus 1. So in this case the 63rd is 580, the 64th is 590, so the 90th percentile is going to be equal to 585. And this is how actually you calculate the percentiles. Now for the quartiles is exactly the same. You have to follow exactly the same steps as the percentiles. P25 is the first quartile, P50th is the second quartile, and it's actually the same as the median, and P75 is the third quartile. So you follow exactly the same steps. You have to calculate the index, check if the index is an integer or non-integer, and then you continue. And these are the steps. Now, the interquartile range is the difference between the third and the first quartile, and it is the range for the middle 50% of the data. The box and whisker plot, it's a box that is based on a 5-number summary. These 5 numbers will be the minimum value, the first quartile, the second quartile, the third quartile, and the maximum. As you can see on the box, the ends of the box have the first and the third quartile. We draw a line in the middle that this is going to be the second quartile, and then on the whiskers we have the minimum and the maximum data value. And this is how the distribution looks like based on the box and whisker plot. This is skewed to the right, this is symmetric, and this is skewed to the left. Now the next step is to calculate the z-score. The z-score shows how many standard deviations an observation is far from the mean, and we have to use the formula x minus x bar over the standard deviation. X will be the value of a specific observation, x bar is the sample mean, s is the standard deviation. So for this example, I give you the age, the x bar for the best actor winners and the standard deviation, and the same thing, the x bar for the age of actresses and the standard deviation. So we have to calculate the z-score. So the z-score for Forrest will be 45 minus 43.7 over 8.8. So that means that he's very close to the mean. It's actually 0.15 standard deviations above the mean, or very close to the mean. And Ellen, 61 minus 36 over 11.5. This is almost 2.2 standard deviations from the mean. So she's far away from the mean. Actually, if a z-score is less than -3 or more than 3, then we consider to have extreme values. These are known as outliers. And this is the explanation for this example.